Sir, from 9:15 to 4:40.
9:15 to 4:40. Okay, fine.
Yes.
So we have Abdul, Annapurna, Maryam, Harsha, Yahya, and Zaina. Only Noha is not here right now. No, I don't think. Okay, so guys, try this question. You have to calculate molarity, and mole fraction of Ki if the density of 20% mass by mass aqueous Ki is 1.202 gram per mole. What you should do is you should take this as 1.20, ignore this 202, take the density as 1.2. So first of all, it will be very easy to calculate the molality. Then from molality, after that you will calculate the mole fraction. Then at last you will calculate the molarity. Okay, molarity will be a bit difficult to calculate, but not very difficult. It will be a slightly difficult than molality and mole fraction. Okay, so please start doing this question. And I can give you one data that the molar mass of Ki 1.2 gram per ml.
Sir, I have a doubt.
Yeah, tell me.
सर टुडे इन टुडेज क्लास सर हमारे क्लास टीचर ने बोला था कि जो आपने जो प्रॉब्लम सॉल्व किया था कैलकुलेट द मास ऑफ यूरिया उसका आंसर गलत है उनको बोल रहे कि 0.4 क्या क्या रहा वो बोल रहे कि पुराने टेक्स्ट बुक में 37.5 था नए वाले में 0.46 है क्या आंसर बोले थे वो
नहीं, एक सेकंड. Regarding this question, right? Uh,
अबव सर अबव वाला
this
ये
one.
सही है ये सही है ये वाला
What is the problem here?
He's saying that आपका आंसर गलत है 37.5 उनको आंसर कोई डिफरेंट आ रहा है वो बोल रहे कि 37.5 पुरानी बुक में था आंसर उसका नई बुक में कुछ अलग है
नहीं, so the question will be also different then, ना?
नहीं क्वेश्चन सेम था उनका बस मेथड अलग था वो बोल रहे थे कि आपका आंसर गलत है उसमें
नहीं, नहीं. They have to, I mean, if it is wrong, what is wrong here?
नहीं मैं सर मैं नोटबुक लेकर था उसमें ऐसा आपको बोलता हूँ पूरा
हाँ.
Sir, can you show the question?
Yeah, so else they can, the only thing they can do different is
हेलो सर, ये उनको आंसर आता 36.9 ग्राम आता
6.9.
है। 36.9।
ठीक है, या आई अंडरस्टैंड दैट, ओके फाइन, दैट्स नॉट अ ह्यूज डिफरेंस। वहां पे उन लोगों ने बस ये किया होगा कि फॉर एग्जांपल हियर वी हैव 2.5 kg ऑफ 0.25 मोलर aqueous solution ना। तो व्हाट दे डिड वाज, उन्होंने मास ऑफ यूरिया को बस घटा दिया वहां से। कैलकुलेट द मास ऑफ यूरिया रिक्वायर्ड इन मेकिंग 2.5 kgs of 0.25 molar aqueous solution. So they would have given some, no, it's not, यहाँ पर उन लोगों ने बस एक चीज चेंज किया होगा, दैट दे हैव सब्ट्रैक्टेड द मास ऑफ सॉल्वेंट। वो भी हम करके आपको बता देते हैं, ठीक है, डोंट वरी।
Sir,
Yeah, Tony.
Molar mass of potassium iodide is
Sorry,
1.2
sorry,
grams.
no, not 1.2 grams per mole. It is 166 grams per mole, my bad। 1.2 तो हमने इसके बारे में लिखना चाह रहे थे।
So, sir, the density is 1.66 gram per mole, right?
Yeah, molar mass is 1.66, not 1.2। गलती से लिख दिया था मैंने। Once you get any one of them, na, molarity, कुछ भी अगर आ जाए, then please let me know. Okay, the first thing that you will do is write 20%, 20 grams of Ki is present in 100 grams of solution. We'll start in that way.
So,
Yeah, sure.
in this, we have the mass percentage of density given and the molar mass of potassium iodide. So,
Yes.
can we substitute that in mass percent and density formula for molarity?
Yeah, into 10, na, divided by molar mass, right? That one?
Yes, sir.
Yeah, you can do that also. So I will give you 2 more minutes. In 2 more minutes, you will send me some answer, okay? At least some answer should be there. Okay, guys, can you please send me whatever you have done till now? Please send me whatever you have done. ओके ठीक है सर ओके प्लीज सर what they have given us is Mariam and Yahya has sent no?
सर मैंने अभी तक मोलालिटी तक किया था, मुझे मोलारिटी और मोल फ्रैक्शन करना है अभी।
Yes, I see that. But mass of solvent आपने 166 कैसे लिखा है?
मोलार मास सर।
And what will be the mass of solvent WA? You've done 20 into 1000 upon 166 is equal to 1.5. ये कैसे होगा?
सॉरी सर, मैं मिस कैलकुलेशन कर, एक मिनट फिर से भेजता हूँ आपको।
ठीक है guys. First they're asking about molality. ठीक है. But what they have given उसको पहले लिखते हैं. 20% means 20 grams of KI in. Yeah, tell me.
This formula for relation between molarity and molality, after finding out molarity, we can substitute it in this formula to get molality.
Yeah, you can do that also. 20 grams of KI in 100 grams of solution. ठीक है. That means I can say 20 grams of KI in 80 grams of solution. Does this make sense? Yes or no, please tell me. 80 grams of solution, my bad. 80 grams of water, my bad. Water, not solution, because 100 minus. ठीक है. What we have done, this is solute, this is solution, and 100 minus 20 will give me the amount of solvent. So I have got the mass of solute, I have got the mass of solvent. I can calculate the molality. Molality can be directly calculated as the number of moles of solute divided by the mass of solvent in kg. So I can write this, the given mass of solute divided by molar mass of solute multiplied by the mass of solvent in grams, and then I will multiply here by 1000. Does this make sense? Yes or no, please tell me. जी guys, बताएं.
Yes, sir.
This makes sense,
Yes.
है ना? तो WB will be equal to how much? 20 into 1000 divided by the molar mass of the solute is 166 multiplied by 80. So 0 and 0 will cancel each other. 2 4s are, and I can do this as 250. है ना? 250 को अगर 4 से मल्टीप्लाई करेंगे then you will get 1000. ठीक है. 4 into 250 will be equal to 1000. So we have now 250 divided by 166. So 166 का आधा कितना होता है? 166 half is 80. 160 plus 80 will be approximately, this will be approximately equal to 1.5. 1.5 moles per kg. ठीक है. So this is easier way to do. Now I have the same thing, 20 grams of KI. So 20 grams of KI and 80 grams of H2O. From here I can get the number of moles of KI. Okay, number of moles of KI will be equal to 20 upon 166. I can get from here number of moles of water also. Number of moles of this I will write B, and this I will write as A. Number of moles of water will be equal to 80 upon 18. 18 is the molar mass of water. Does this make sense till here? Yes or no, please tell me. Yes or no?
यस सर।
Yes, sir.
ठीक है. So 80 upon 80 will be 4 upon 40 upon 9 and 20 upon 166. 20 upon 166 को थोड़ा सा बस ये कर लेते हैं, that it will be 166 का half कितना हो जाएगा? 83. So this will be 10 upon 83, number of moles of solute, and Na, number of moles of solvent, will be equal to 40 upon 9. So you can calculate the mole fraction of solute. Chi b will be equal to 10 upon 83 divided by 10 upon 83 plus 40 upon 9. तो 83 81 काफी सिमिलर है, काफी नजदीक है. दैट मींस आई कैन अप्रोक्सीमेट कि हम यहाँ पे 9 से मल्टीप्लाई करते हैं ऊपर नीचे, है ना. सो आई विल गेट 10 upon 83 as it is in the numerator divided by 10 plus 9 4s are 36. So this will be 360 divided by 83. ठीक है, approximations है यहाँ पे. Please understand that. So I can eliminate this 83 and 83. I will get this as 10 upon how much? 370. So 1 upon 37 I'm getting as. I hope there is no calculation mistakes here. I think this will be fine. So this will be approximately 0. कितना हो जाएगा 37 ना. So 37 will be 0.1 upon 4. 1 upon 4 होता है 0.25, है ना. तो 0.25 थोड़ा ज्यादा 0.02627 के करीब आएगा. ठीक है, 26 और 27. ठीक है, 2627 बोथ विल वर्क बिकॉज उतना मार्जिन ऑफ एरर चलता है. ठीक है, राइटिंग है 237 लिख देते हैं अप्रोक्सीमेशन से. ठीक है, बाय द वे दिस अप्रोक्सीमेशन को हम कैसे करते हैं ना, हम बता देते हैं आपको. 1/4 इट इज इक्वल टू 0.25. दैट मीन्स 1/40 विल बी इक्वल टू 0.025. ठीक है, now 37 is less than 40. So if the denominator is lower, the whole value will become higher. So I have just slightly increased 0.025 to 0.027. Does this approximation make sense to you guys? Yes or no, please tell me. From 1 upon 4 to how to calculate 1 upon 37. ठीक है, now next the last case that we have to calculate is molarity. And we have the same thing available. The only new thing that we have is density. ठीक है, so I will not be using the formula for density. जिनको formula याद है उनके लिए बहुत अच्छा, but still what we have is 20 grams of Ki in 100 grams of solution. This is the base with density is equal to and D is equal to 1.2. ठीक है, so from 20 grams of Ki I can get the number of moles of solute, and we have calculated this already. This is 10 upon 83. 20 upon 166, that is 10 upon 83. ठीक है, now from here I have to calculate the volume of solution. So volume will be equal to what? We know that density is equal to mass by volume. So volume will be equal to mass upon density. So what is the mass? 100 grams. What is the density? 1.2. So you can write this as 100 upon 12 by 10. This will be equal to 1000 upon 12. This will give you in ml. If you want to have this whole thing is ठीक है, if you want to have this whole thing in liters, this is ml. You have to divide this thing by 1000. So volume will be equal to 1000 upon 12 into 1000. This will be equal to 1/12. ठीक है, so volume is equal to 1/12 liters. Now molarity will be equal to 10 upon 83 divided by 1 upon 12. So this will be equal to denominator will go above numerator. 10 into 12 upon 83. So it will be 120 upon 83. 120 upon 83. So this will be also approximately equal to 1.5, 1.45 के करीब कुछ होगा. Because 120 upon 80 रहता तो it will be completely equal to 1.5. Now it will be slightly less than 1.5. Okay, this is coming as 1.45 molar. ठीक है, so this question is the ultimate question that you should practice whenever you are doing solution chapter. ठीक है, बिकॉज यहाँ से आपको मोल फ्रैक्शन, मोलारिटी एंड मास परसेंटेज, ठीक है, तो बहुत कम वैल्यू से यू आर गेटिंग टू मच वैल्यूज, है ना। आप अगर देखिए यहाँ पे व्हाट इज द ब्यूटी ऑफ दिस क्वेश्चन इज हैव बीन गिवन ओनली टू नंबर्स, 20% एंड 1.202, एंड ओनली फ्रॉम टू नंबर्स यू आर एबल टू कैलकुलेट सी थिंग्स। ठीक है, सो दैट इज व्हाई दिस क्वेश्चन इज क्वाइट इंपॉर्टेंट टू रिवाइज द concentration terms. Please copy this down. Let me know if you want me to explain any one section once again. मोलारिटी आया था आपका, ठीक है। मोल फ्रैक्शन 0.02. ओके, हर्षा वाज गोइंग टू कैलकुलेट। अच्छा, मोलालिटी आपका, मोलालिटी थोड़ा कम नहीं आ गया? कितनी है? क्या 1.44 है? क्या 1.45 ये भी है? 50 अपॉन 166।
Yeah, the last one is molarity.
First one is molality ना?
Yes, sir.
That will be 1.5 only.
Okay.
Okay, वो 1.45 नहीं होगा। अन्नपूर्णा तो हमने नहीं देख पाए थे हम। मोलालिटी 1.5। अच्छा, मोलारिटी यू वर कैलकुलेटिंग, ओके अन्नपूर्णा। Please raise your hand once you're done writing. Waiting for Abdul and Zaina. Also guys, अगर आपने किसी दूसरे मेथड से स्टार्ट किया है, अपने आंसर लेके आए, इट इज कंप्लीटली फाइन, ठीक है, यू डोंट हैव टू वरी अबाउट दैट। Okay, whatever a method, whatever a formula comes into your mind, use that formula and do the question. Question should be solved, that should be your main purpose. Okay, Abdul, just waiting for you. Now, moving on to the next question, जिसमें 36.9 basically 37 or 37.5 के बारे में सवाल था. See, in this, the way we did this question was that we took this 0.25 molar aqueous solution, that is 2.5 kg of aqueous solution, and we took 2.5 kg as the mass of solvent itself. Right? It was given as mass of solution, not solvent. I completely agree with that. But since the concentration is very low, the mass of solution and the mass of solvent does not vary too much. And that is why the answer we are getting, it is in the marginal error area. For example, if you have error in the answer of 5%, that means the correct answer is, let us suppose 101, and you are getting the answer as 104, then both of these answers seems it is marked as correct itself. Okay. Now, because there is a 5% calculation error उसमें माना जाता है. Now, how to get the answer? And if you want to take this 2.5 kg as the mass of solvent only, then in that case, what you have to do, you'll have write this particular statement 0.525 molar aqueous solution. What does it mean? It means 0.25 moles of urea in 1 kg of solvent. Okay, in 1 kg of solvent. Now, if I calculate the mass of 0.25 moles of urea, then we saw that molar mass of urea was 60 grams per mole, right? So 0.25 into 60 will be equal to how much? 0.25 into 60 will be equal to 1.5 and 15. Will be equal to 15 grams of urea in 1 kg of solvent. Now we need to know the mass of urea required to make 2.5 kg of 0.25 molar aqueous solution. So I want to convert this statement, which is 15 gram of urea in 1 kg of solvent, then in dash kgs of solution. In our solution, we have only two things. We have solute and we have solvent. Solvent, how much? 1 kg. How much is solute? 15 grams. So I can write the 15 grams of urea is present in, if I want to convert this 1 kg, and I will add 15 grams, it will become 1.015 kg of solution. So 15 grams of urea is present in 1.105 kgs of solution. अब यहाँ से ना, we will reverse the statement. How we will reverse this? We will write 1.015 kg of solution has 15 grams urea. That means 1 kg of solution has 15 upon 1.015 kg of urea. And this is all now unitary method. 2.5 kg of solution has 15 upon 1.015 into 2.5 kg of urea. Once you solve this will come as 37 grams approximately. And 36.9 जैसे कह रहे थे ये 37 grams. ठीक है, so you can write this also. Raise your hand once you're done writing. Just waiting for Yahya now. Okay, we're gonna start. ठीक है. So, right, next. Write the topic solubility. Okay. Now, from here, the new part of solution chapter is start. Like all of these things, whatever we have learned till now, it is more or less old things that we have learned that was also present in the class level. Now, what is solubility? Please write with me. Solubility is the amount of solubility is the amount of a substance that can be dissolved in fixed amount of solvent at a given temperature. Now, what the definition is saying? This is just saying that, for example, you take water, you add some sugar in it, you dissolve it, then you add more sugar, you dissolve it, you add more sugar, you dissolve it, you keep on adding sugar and you keep on dissolving it. There will be a point after which no sugar can be dissolved in the water. So the maximum amount that you can dissolve in a particular amount of solvent, that is known as its solubility at a given temperature. It is temperature dependent, because if you are going to heat the water and you keep adding sugar, then that sugar solution, it will become sugar syrup. And sugar syrup is what? It is at different temperature. So if you are going to increase the temperature, solubility will also increase in terms of solid. Okay. So we are going to look at different factors that affect the solubility of solids in liquid. And after that, we are going to do the factors that affect of solubility of gas in liquid, and liquid in liquid will be later on. Okay. So there are only two things that you have to learn: factors affecting solubility of solids in liquid, and then the factors affecting solubility of gases in liquids. So write the first heading: factors affecting solubility of solids in liquids. The first thing is nature of solute and solvent. Nature of solute and solvent. Meaning, if I add sugar, it will be a bit difficult to dissolve sugar in water. But if I dissolve salt in water, it will be very easily dissolved. So that means the nature of solute also, it matters. Sugar, it is not getting dissolved very easily, and salt, in the other hand, it is getting dissolved very easily in water. But if I have to dissolve same salt in honey and water, if I change the solvent now, then also the solubility will change. So nature of solute and the nature of solvent both affect the solubility of solids and liquid. Next is pressure. So it has no effect. It has no effect as solids are rigid. Solids are rigid, that is why there is no effect. Third is temperature. That means pressure, it does not have any effect on solid. That is why it will not have any effect on the solubility of solids also. Okay. Now temperature में क्या होगा? Please see. If you have some molecule, ठीक है, ऐसा करते हैं, इसको एक काम कीजिए, इसमें दो हिस्सों में डिवाइड कर सकते हैं ना. इफ डिसोल्यूशन is endothermic, that means you have to give heat in order to dissolve something, then we say that dissolution is endothermic, that it absorbs heat while getting dissolved. So if dissolution is endothermic, then in that case, increase in temperature, solubility will also increase. But on the other hand, if the dissolution is exothermic, then when I'm going to increase the temperature, the solubility will decrease. So these are the three things that you have to remember. Now, next thing that you will write for solids and liquid, the general rule for solubility it is like dissolves like.
Sir,
Yeah, tell me.
in exothermic, temperature increases.
No, I'm not saying temperature increases. If you increase temperature, solubility decreases. That's how you should read this. Dissolution is endothermic. Then when you increase the temperature, solubility increases. If the dissolution is exothermic, if you increase temperature, solubility decreases. Makes sense now?
Yes.
Like dissolves like. Okay. So what does it mean? It means like means the type of interaction that is present in solute and solvent. If both of them are same, then they are going to dissolve each other. That means if they are both are polar, then polar will dissolve polar. If it is non-polar, non-polar will dissolve non-polar. Okay. So you have to write polar dissolves polar molecules. Non-polar dissolves non-polar molecules. Okay. Now, basically, most of the organic compounds that we have, they are generally non-polar. Okay, so please copy this down, Hatak. Then we'll see a few questions.
Sir, can you give example of polar and non-polar?
हाँ, polar आपके पास जैसे you have water, it is polar. ठीक है, water is completely polar. It is even like very polar hydrogen bond. Similarly, NaCl is also what? Polar. Na is completely positive, Cl is completely negative, so there is a dipole moment here. So both of these are very easily dissolved. But if you want to see, like for example, water and glucose, okay, so C6 H12 O6, okay, and it has a structure like this, plus minus plus plus. Okay, so this is also slightly polar, but it is not as polar as NaCl. That is why, I mean, glucose का combination से ही sucrose रहता है, जो कि you have in sugar. That is why you see that if you are going to dissolve glucose in water, it will be a bit difficult to dissolve it. And I don't know if you remember, if you dissolve glucose in a steel glass of water, and if you are going to touch that steel glass of water, it will feel a bit cold, Now, why it will feel a bit cold? Because whatever heat was present in the steel, that heat is absorbed by the dissolution process. And when heat is absorbed, what will happen? That steel glass will become a bit cold. Okay, so water is an example that it dissolves very easily the polar molecules. Now, NaCl is completely polar. This is slightly polar. That is why it is able to dissolve, but not completely. अब वहीं अगर हम नॉन पोलर की बात करें, so for example, you have water and then you have oil. So oil is complete what? It is oil. अगर आप लेके चले, for example, the cooking oil, then it is alkene. So alkene is completely non-polar, and that is why water and the oil, they do not dissolve with each other, because one is polar and the other one is non-polar. Similarly, if you have you seen those क्या बोलते हैं उसको, thermocol? You have seen thermocols, yes or no?
Yes, sir.
Yes, sir.
Thermocols you have seen, right? So what will happen if I put thermocol into water? Will anything happen? Tell me, guys.
No, sir.
It won't dissolve.
Nothing will happen. It will be as it is, right? It will float in water maximum. That will happen, right? But let me just show you what happens if you dissolve, if you put thermocol in petrol or any type of oil. Okay, so petrol is also oil. It is also going to contain hydrocarbons only. Okay, just let me show you guys. I mean, there is this one Indian guy who does all these type of stuff. No need. I'm not. Just give me a second. Can you guys see the screen now?
Yes.
Okay. So this is, let me show you. So this is thermocol. You can see how large sheet of thermocol is there, and there's small amount of petrol or diesel. I don't know what he has bought. It can be any one of them. And see what happens. Should I turn the sound on? Do you need the sound?
Yes, sir.
Yes, I find him a bit irritating. So
आई होगी तो यहाँ पर भाई साहब ये भी इसके साथ रिएक्ट करने लगा है और ये भी नीचे जा रहा है इसमें। और भाई साहब यहाँ पर ये थर्मोकोल भी देखो पूरा का पूरा इस पेट्रोल में, और भाई इसके अंदर जो चीज बनी है वो भी यार एकदम अजीब सी ही चीज है। मतलब मैं सही बताऊं तो ऐसा लग रहा है जैसे कुछ हलवा हो या कुछ ग्लू जैसी चीज लग रही है। तो गाइस इसका ग्लू टेस्ट करने के लिए मैं यहाँ पर इस मटेरियल को डाल रहा हूँ एक लकड़ी के ऊपर, ठीक है, और इसको थोड़ा सा यहाँ पर हम लोग सूख जाने देते हैं ताकि पेट्रोल उड़ जाए, और फिर इन दोनों लकड़ियों को आपस में चिपका देंगे। और भाई साहब ये वास्तव में बहुत ज्यादा हार्ड इसको चिपकाता है यार, और ये बना है सिर्फ थर्मोकोल को पेट्रोल में डालने से भाई साहब। और आप दोनों फेसेस को भी देख सकते हैं यार, कमाल की चीज है।
ठीक है, so you saw like how fastly it is dissolving. It is not, there is no reaction actually happening. It is just dissolution. जैसा कि अगर if you have a very large like if you have a very large rock salt type of thing and you put it in water, then also it is going to dissolve in a similar manner, no? And it formed a kind of slurry kind of thing. The similar kind of thing is formed without any color, obviously, when you have the sugar syrup also. Like it is very thick and it is also very sticky, right? So similar thing is happening when you are dissolving petrol and thermocol. Thermocol is also non-polar and petrol is also non-polar. Okay, so these are the examples, as Mariam asked. How did you like the guy? Did you like the guys? Do you like him?
Yes, sir. Yes, sir.
Yes. इतना आवाज रहता ना यार उसके, इसमें बैकग्राउंड म्यूजिक इतना ज्यादा रहता है कि क्या बोलते हैं।
No, sir.
नहीं पसंद है। Okay. By the way, the guy is an IITian and like he started this channel by doing this kind of random stuff. was in IIT Roorkee, I guess. Okay, moving on. So we have general rule for solubility is this, and there is one question that you can attempt. Okay, this is on dissolving ammonium chloride in water at room temperature, the solution feels cool to touch. Cool to touch. Now, a solution will feel cool to touch only when it has. चलिए आप इसको कीजिए जरा पहले कीजिए फिर हम बताते हैं इसको. I will explain and I will give you the answer. Okay, Zaina. So guys, one more minute. This question was asked in last year's paper. थोड़ा सा मैं बता देते हैं because you guys are not answering. You have to answer on Zoom chat and you have to send it to Salim. Whether Annapurna, can you message me anything? Because last time आपके message नहीं आ रहे थे.
Yes, sir.
Okay, Harsha. Can you message something in the Zoom chat? If the solution is feeling cold to touch, that means whatever heat was, for example, if you add water, water will have certain temperature. Like if you have any kind of temperature, that means it is having a certain amount of heat. And if the solution feels cold to touch, all that heat is used for the dissolution process. Okay. Annapurna, did you answer?
Yes, sir.
Oh, I have still not got your answer. I think you are sending it to Learnivio.
No.
No. Can you send me a photo, like from your phone? Can you click a photo, like in front of the chat box and send it to me? Because if that kind of thing is happening, then I will tell the Learnivio team to look what's happening. So, I mean, when you have texted, it is saying you to Salim Raza, direct message in brackets. ऐसे लिखा रहा है?
Yes, sir.
Just send me a photo. I will forward that photo to the team and they will look what's happening. I think, okay, yeah, has got. Okay. Now, okay, Mariam has also got. Okay, देखिए. So, as I said, it is feeling cool to touch. That means if you are having high amount of heat, then the solution will dissolve faster. So, to have high amount of heat, you should have hot water. Now, when you have hot water, whatever heat is present in the water will be used for the dissolution process. And obviously, powdered salt will be dissolved faster than the saltless salt. That's why B would be the correct option. Okay, powdered salt in hot water. And Puna, please take a photo of the chat box and send it on my WhatsApp. Okay, I will forward it. I will forward that to the team. Now, right next.
Sir, I replied to the chat you sent.
You replied to me. जी हाँ हाँ ये अब आया मेरे पास. I got that. That's correct. Right next. Factors affecting solubility of solids in liquid. Solids in liquid तो हो गया ना, गैस एंड लिक्विड करते हैं. ठीक है ना, गैस एंड लिक्विड में आप खुद ही से बहुत आसानी से आंसर कर देंगे. सबसे पहला तो आपके पास क्या है, नंबर 1 इज नेचर ऑफ solute and solvent. Next is temperature. ठीक है, ध्यान दीजिए. If you have certain amount of liquid and you have gas dissolved here, ठीक है, you have gas dissolved here, and when you are going to heat it, so what do you think? What will happen to the gas? Will it dissolve more or will it escape out?
Escape out.
It will escape out, right? So you can say that solubility is inversely proportional to the temperature, right? Make sense? Yes or no, please tell me.
Yes.
Okay, right here, one more point. Now, this particular, it has an application. The application is aquatic animals. Aquatic animals are more comfortable in cold water. Why in cold water? Because in cold water the temperature is low, and if the temperature is low, there will be more oxygen dissolved. The dissolution of oxygen will be easier in cold water. Okay, aquatic animals are more comfortable in cold water than in warm water because in lower temperature the solubility of oxygen is higher than in higher temperature. Okay, because when you have lower temperature, the solubility of oxygen is higher than in warm water. डायरेक्ट ही इसी तरह के सवाल भी आए हुए हैं आपके पास. ठीक है, let me just show you guys. Why aquatic animals are more comfortable in cold water than in warm water? ठीक है. If you're done writing, we'll write next point, pressure. So obviously, if we apply pressure into this particular system where we are having where we are having gas inside the liquid, then what will happen? If you're applying more pressure, the gas will still be inside the solution. So we can say that solubility is directly proportional to pressure. If you're going to increase the pressure, then what will happen? The solubility is going to increase. Okay, so you can write one more here, the solubility of gas at a given temperature is directly proportional to the pressure at which it is added.
Sir, can you give an example?
Can I give an example? Have you ever opened a Coke bottle, Zaina?
Yes, sir.
Do you see that a large amount of gas escapes out as soon as you open it?
Yes, sir.
Right? That means when we were filling the bottle, we filled the bottle at a very high pressure so that the CO2 is mixed inside the Coke, and the soda water, it has CO2. The CO2 is mixed inside the water at a very high pressure so that the solubility increases. So it is bottled at a very high pressure, but as soon as you open the bottle, the pressure is released. And when the pressure is released, what would happen? Pressure is decreased from like the very high pressure 2-3 atm, and it decreases to the normal pressure, that is 1 atm. Okay. So when it is decreased to 1 atm, then what would happen? That's why the gas escapes out. So as the pressure became low, gas escaped out, and when the gas escaped out, I can say that the solubility has become low now. Gas is not getting dissolved easily. Does that make sense?
Yes, sir.
Is everyone done? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
So that's it for today. Okay. I think till maybe this Ramadan we'll be having approximately 1 hour class, 1 hour 15 minutes class. Okay. After Ramadan, it will be of 1.5 hours. And since we have done a very small topic today, so there is no questions. You will get questions in the next topic, that is Henry's law, which is related to the factors affecting the solubility of gas and liquid. And since we are doing the pressure part का mathematical form है Henry's law. We will be starting with Henry's law tomorrow. In Henry's law, you will get all many types of questions from boards also. We'll do some questions from the GE also. Okay. And we'll meet now on what? We are going to meet on 25th and 27th. Then I think we have 2 more weeks, and then we will go back to 1.5 hours. Yeah. So that's it for today. And we will meet on Monday. You will get a few homework. Please do your homework. And Abdul, you did not send me any photos of the notes. And those guys who are sending the photos of the notes, please keep that. I mean, please keep sending me the notes. And do one more thing, like add a date. As I add dates now, आप लोग भी अपने notebook में ना date add कर लें. So it will be easier for you to remember what is happening on what date. ठीक है? So if it is in a long one continuity, it will be, वो थोड़ा सा बाद में रिवाइज करना आसान नहीं होता है. You put on dates, it will be easier for you to remember. Okay, fine, यहाँ पे ये हो रहा था. Okay, fine, उस दिन यहाँ पे ये हो रहा था. ठीक है? So with the dates ना, जैसे आज आपके यहाँ आज आपको कुछ हुआ होगा, मान लीजिए आज आप किसी का स्कूल स्टार्ट हुआ होगा आज, है ना, या तो किसी घर में मेहमान आए हुए होंगे. So whatever content we are doing today ना, you can remember it by that particular event that happened at your own life. So sometimes that also help to remember the content. Okay, so please keep adding dates. चलिए, I saw some of the students, they are adding dates, very good. And बाकी लोग जो notes भेज रहे हैं, please note भेजिए. Abdul, you were trying to say something.
Sir, I said I'll send it to you.
टुडे?
ये सर ठीक है।
ठीक है, जायना एंड हर्षा। हर्षा आपने भेजा था क्या? हर्षा नहीं, आप शायद डिस्कनेक्ट हो गए थे तो आपने नहीं भेजा था ना?
Yes, I didn't send.
बाय द वे, यही है, यू हैव टू सेंड, हाँ हाँ